let's do something a bit more interesting with our code, with methods, and if you're writing in Python, functions as well. We're really going to up our game here and enable some sophisticated complexity, really improve our algorithms and our overall program design complexity with these. At the end of the day, methods and functions are the behaviors of our code. We already know how to store data into variables and things like arrays and lists. We know how to process conditions. We know how to work through logic in different ways. We even know how to loop over content, and even how to understand what a template is, which is a class, and how those get instantiated into objects that can actually do things in our program. But these objects, they need behaviors, things to do. There are methods and functions. Just so you know, methods are all that Java has for behaviors, whereas functions are things that Python also offers. So Python does methods and functions, kind of the same thing, it's just different contexts, whereas Java just sticks with methods. You'll learn more about the specifics of those in the branching videos for each language, however. So methods and functions are the behaviors of our program. However, there's a few more factors about them we need to understand well. The second thing being modularity. They are modular, meaning they are independent things that each have a specific function or role in a larger system. A great way of imagining this is to think about building a house. A house is a really complex thing. It has walls, framing, roof, maybe a driveway, stairs, but it also has things kind of hidden away inside of it, like electronics. It might have some piping for the washroom or the shower. It might have a whole bunch of different types of furniture or electronics inside of it. It's a really massive, complex thing. And it's pretty rare for one person or even one group of people to make the entire thing. You usually have modular teams. So you might have a team that digs out the foundation, and then another team that lays the concrete, another team that puts in the rebar, another one that does the framing, another one that puts in all the way to the house being complete. You have modular components that are each responsible for specific and well-defined behaviors. And then when you have all these operate in a certain logical order and combine their efforts together, you can have a lot of complexity and a really sophisticated, diverse final program, or house, if you'd rather, come out emerging from it. So we don't want everything to be all solved in one big messy go. We want modular pieces to all be working in tandem, which is what methods and functions really enable our programs to be able to do. So modularity is at the core of things here. They're also independent. Ideally, each method is able to perform its own unique task that other ones don't. This doesn't mean that they don't interact, right? I can be an independent person, but I still interact with other people. Maybe I even collaborate with them sometimes. Maybe I rely on them. I ask for advice. I maybe get a loan. Maybe I want to express some feelings, and maybe I just want to connect personally or intimately with somebody else. Being independent doesn't mean there's no connections, but it does mean that there's something about me that's uniquely myself. And methods and functions should be independent, even though they do interact and pass along things all the time. Finally, they're kind of designed to usually be repeatable, meaning I create some kind of behavior that I might want to trigger many, many times. And maybe in different ways. Maybe one time a method or a behavior performs an action once, another time it performs it 5 times. Maybe one time it performs an action on the protagonist of the game. Maybe another time it performs an action on the antagonist of the game. Maybe one time it performs an action that adds data to a certain section of your code. Maybe another time, because of some condition, it instead adds the information to a different place. So there's lots of unique behaviors that can occur, but we want to have repeatable behaviors that's just really efficient, really generalized, and there's a lot of awesome stuff that comes from this. So what does a method look like? We'll study the specific ways these methods and functions for Python look in those videos, but for now, here's a simple example. I've written on this piece of paper a basic outline of a method. This is a jump method or behavior. And how does it work? Well, if I call it, let's say this is like a card that I pick up, maybe I'm doing like a relay race, and I get to a station and my job is to pick up the top card and do what it says. And this one says jump. this jump has instructions. This is the body or the content of the method or the behavior. It says hop on 1 foot. So you can't actually see this. Hopped on 1 foot. You have to just believe me. I didn't cheat and do 2. I wouldn't do that to you. So here's a method. We can think of calling a method by doing something like this. Maybe this is our program, a nice little page to represent it, and I'm at a spot where logic's being processed. Maybe it says jump, which tells the program to perform the behavior defined as or labeled as jump. So my program gets here and I go, boop, this is what lines up with this. What's tucked underneath? These instructions will be somewhere else in my program. It'll refer to these and the program will perform that action. Or maybe I have, after jump is called, I have a fancy jump. Another behavior that I've created, a fancy jump. Let's see what's involved in that. So I do my jump, hop on 1 leg. Next thing, fancy jump is called. This behavior is called on. What are the instructions? Hop from 1 foot to the other and then clap. Pretty fancy. So let's go 1 foot to the other. Whew. This is a crazy, complex, super in-depth lesson. So fancy jump, I performed a different behavior that's tucked away inside of this modular, independent, but repeatable piece. I could call this fancy jump a bunch more times, maybe in a loop if I wanted to drive Mr. Rowell crazy. I could also have a method that is able to accept a variety of information. I have this number sign in here that's a placeholder for some number that I send to it. So this repeat jump, the way that this method would work is if I call on it, I say repeat jump. Inside of these brackets, I might put the number 3. I could make it 1, 2, 3, 10, 500. And what is the behavior when I call on this? Perform the jump method number times. Whatever number I sent, that many times. Interesting. So not only can I send a method information, but I can also have one method trigger another method. That's totally allowed. So this method says repeat it a number of times. So this method is called on repeat jump, call on the information, take a look at the instructions, repeat it 3 times. So now this calls on jump once, hop on 1 foot, calls on it again, hop on 1 foot, calls on it a 3rd time, hop on 1 foot. Now this is complete and I can move on to the next part of my code. Got one final one for you, and here we're gonna see something absolutely magnificent. I've labeled this method dance routine. Dance routine. This method, once it's called, pops open its reference, and its behavior is a big chain of my other methods and behaviors all together. It's kind of like a choreographed routine, and really a lot of what we're doing inside of our code is choreography. Right? We're kind of setting what is the order of behaviors I want to trigger and to have some kind of outcome. It really is kind of like a dance to write code with all these different methods, really. So my routine is I perform, where did I put it here? Let me get my things laid out here. Here we go. First step, perform jump, hop on 1 foot. Next, I perform fancy jump, 1 foot to the other and clap with the paper in my hand. Then I do my repeat jump 3 times. The way that it works is I go jump, 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 and finally, what do I got here? Oh, I do my fancy jump again, over, clap, and finally, I get to sit down. Finally. We're not quite done yet though. So our methods are these behaviors that are modular. Notice each one of these is a separate sheet off on its own. It's independent, but they can interact and relate to one another. They're able to receive information. They're actually even able to send information back out. Not relevant in this example, but I'll show you some examples of that in the code that we write. And these are always attached to objects. At least in Java, we're able to separate them out from objects in Python with functions, which are behaviors that don't attach to anything. They're just kind of generic instructions for some kind of action that we can use. And when you take your branches, you get to see how these work in Python and Java. Enjoy. Look forward to seeing the cool things that you get your code to do in the future.